However, you are going to take notes. So, topic, this is the first half of 3.4. It says solving exponential and log equations. Today we're going to focus on the exponential equations part of it. We have three formats to our exponential equation, so I will very strongly highlight those as we go through. But one of the important things that we need to remember when dealing with exponential and logarithmic equations is how do I flip back and forth between my exponential format and my logarithmic format. If you're really good at that, great. If you're not, write down a little reminder for yourself, because you have to solve an exponential or a logarithmic equation, you have to be able to flip back and forth between them. They are inverses of each other. That's how we undo one or the other, okay? So, three types of exponential equation. The first type is exponents on both sides of the equation. So if we have exponents on both sides, then we will change it so to make the bases the same. Now, we're going to kind of increase in difficulty as we look at these. Our first example, 4 to the x plus 2 equals 16 to the x minus 3. Once we have the bases the same, our exponents have to be the same. The first thing I would do is take the smaller number, 4, go to the bigger number and say, can I write 16 as 4 raised to something? The answer to that is yes. Okay. So that's what we would do. It is still going to say 16. But it's going to look different. It's going to say 4 squared. Still 16, right? So I haven't changed that. Everything else stays the same. So it's still 4 raised to something and 16 raised to something, right? The 16 just visually looks a little different now. But now I have it written with the same base on both sides. And as soon as you get it to have the same base on both sides, then the exponents have to be equal to each other. If it's 4 raised to something equals 4 raised to a different something, those somethings have to actually be equal, right? So now I can just zoom in on the exponents and say x plus 2 has to equal. And if you ever have a binomial here, make sure you group it so that we distribute in our solving process, okay? Questions so far? Okay. The rest is quick algebra here. Solve, get my x's on the same side. We get x equals 8. Okay. It's this part that people mess up on, and let me make sure that I'm very clear. You cannot change the number. It still has to say a 4, and it still has to say a 16. But you can change how it looks. So it still says 16 right here. It just looks like 4 squared. Okay? What I can't do, and this is the mistake that people want to do, is they take that same problem and they say, oh, well, I can just square the 4 and it'll match the other side. So I square that 4 and say 4 squared times x plus 2 equals 16 to the x minus 3, which would be 16 to the x plus 2 equals 16 to the x minus 3. Can't I just do that? Now my bases match, right? But is it still 4? No. I changed the number. I squared it and I changed it to a 16. Over here, I did not change the number. I just changed how it looks. It is literally still a 4 and still a 16. Those did not change. And notice the difference between them. If you change the number, you've now made that a different problem. Okay, we cannot do that. We have to keep it the same numbers as we go. Any questions on that? Okay. This is wrong. I cannot do this. Doesn't it look like the same? Yep, and that's usually going to be incorrect because I literally changed this from a 4 to a 16. I never changed this number. It's 16 here, it's 16 here. It's still 16 as we go down. It just looks different. So that's why this is easy to do, because it looks so much the same. Okay, so increasing our difficulty as we go. That was a pretty basic one. Dealing with fractions. There are kind of a couple different ways we could go about attacking this problem. So I have a 1/3 to the x equals 1/81 to the 2/3. We're going to talk about a second option after we get done with this problem. But I'm always going to encourage you to use the smaller number and say, can I rewrite my bigger number as that raised to something? Now, when I say smaller and bigger, I'm not meaning the actual fractions. If I look at the denominators here, or like the individual numbers, I would look at the 3 and say, okay, can I rewrite 81 as 3 raised to something? Do we know that? It's 3 raised to the 4th, okay? So yes, I can. Now, it's not 3 and 81. It's 1/3 and 1/81. But I really can, because 1 raised to anything is going to stay the same, right? So I really could make this still say 80. This is still going to say 1/81, but it's going to look like 1/3 raised to the 4th. This is still 1/81, right? You with me? Okay. So I have not changed that number. I just changed what it looks like. Same problem. All that's changed is this now looks a little different. Same number. But they now have the same base. And once they have that same base, I can now just look at the exponents and write that equation. X equals 4 times 2/3. Make it look like a fraction. Multiply straight across the top, straight across the bottom. 8/3. Yeah. Yes. Always make it something smaller. Smaller raised to an exponent. Okay. With that being said, any questions on that? Okay. Now there are people out there that have a very strong aversion to fractions. And they just see that and kind of shut down on me or don't want to deal with it. I don't know what 1/3 I can raise 1/3 to give me 1/81. You guys, you do have an option, and this is not wrong, and if you thought about doing this to start with, you could have. I could rewrite these both as 3 raised to something. 1/3 is 3 raised to the -1, right? That's how I'd move it out of the denominator to the x. And I really can write this as 3 raised to something. It'd be -4th. So you really can get rid of the fraction-looking thing if you would like to, using negative exponents. Keep that in mind on this next problem. Questions? Okay, the next one is tricky though. This is definitely not a straightforward problem. I want you and your table partner to see if you can come up with an option. Okay, it is not as straightforward as it seems. 2/3 to the x minus 5 equals 9/4 to the 3/4 x.
Maybe not. It's not as
What?
but it is simplifying. They are simplifying.
Yeah. Oh, no. Because there is a 2 that goes into the, yes, but not rewriting it as 2 and 1/4. Not going, no, don't make it or mixed numbers or whatever. Okay, did I have anyone that thinks they came up with something you could maybe do? Okay, what do you think? How? Negative. A negative exponent. Remember on the last one we talked about a negative is going to move the number to the other part of the fraction. So let's talk through this. Use the smaller numbers. Our smaller numbers that we see in here are a 2 and a 3. And I say, okay, can I raise 2 to something to give me, and look over here, 2 squared is 4, right? 3 squared is 9, but they're in the other part of the fraction. So to move something to the other part of the fraction, we have to use a negative exponent. So yes, I'm going to write this as 2/3 squared to get the 4 and the 9, right? But to move it to the other part of the fraction, because when this gets squared, I need it to end up in the bottom, I put it as a negative. So squaring it is going to make it 4, the negative moves it to the bottom. Squaring it is going to make it 9, the negative is going to move it to the top. I'm back to 9/4. That's the trick on this one. So if we ever need it to end up in the other part of the fraction, use a negative, right? Okay. Any questions on that? Zoom in on your exponents, write the equation. Okay. Remember that with fractions, and yes, I get that you guys have calculators. Sometimes it's even faster to not use my calculator, right? Multiply straight across the top, straight across the bottom. 2 times 3 is 6. 1 times 4 is 4. Simplify the 6 over 4. We're looking at -3/2. I don't have a calculator up here with me, so I'm going to continue to talk in fractions here. When I subtract 1x from both sides, -3/2 minus 1 would be like -1.5 minus 1 would be -2.5, right? Which I'm going to leave as 5/2 because, again, I don't have a calculator in my hands. So you can grab your calculator and divide by 5/2, or me without a calculator, I'm going to multiply by its reciprocal. Okay, well, 2/5 times 5? 2, right? Don't your 5's cancel? Negatives cancel. We get x equals 2, which my calculator can tell me also. Okay, any questions on that? Okay, we have one left of this variety where there's exponents on both sides that we need to talk about, and that is this one. 9 to the 3x equals 27 to the x plus 1. Looks very simple and innocent to start with, very much like the first one we did. I would again encourage you to use the smaller number. Okay, 9. So I come over here and I say, can I raise 9 to something to give me 27? When the answer is no, this is the last variety we're going to see, is we're going to have to change both bases. So now I have to come up with a different number that I can use to rewrite both of those as, and that number would be 3. This is still going to say 9 raised to the 3x. This is still going to say 27 raised to the x plus 1, but I'm going to write them as 3 raised to something. So 9 would be 3 squared. 27 would be 3 cubed. So keeping in mind, guys, and I am stressing this because it a lot of times will go the wrong way, it still has to say 9. It still has to say 27. It can just look different. And once we get that adjusted, zoom in on your exponents. Okay, solve for x. And once we get to this point, it's just a basic algebra equation. Make sure you distribute that all the way through a binomial. Questions? Okay, that is variety number 1, exponents on both sides. And we've kind of saw a couple different ways of exponents on both sides, but that's how we attack it. Get the same base on both sides, zoom in on your exponent. So when I see this one, if I were to try to do the same idea, 3 to the x equals 7. If I were to try to rewrite both sides as something, the same base, can I write 7 as 3 raised to something? No. So we're going to run into an issue where that's not going to happen. If we can't make the bases on the same side, on both sides the same, I have an exponent on one side. You are going to attack this a little bit differently, and that is this. We are going to solve for the exponential term, which means get it by itself. To get it by itself, we're going to get rid of any outside numbers. So any vertical shrinks or stretches, any ROXs, any ups or downs. Thank you. Okay, we don't have any of those in this problem, do we? So that part's done. Once we have gotten that exponential term all by itself, gotten rid of all of our vertical stretches and shrinks, ROXs, ups and downs, we will flip to a logarithmic equation. Okay, so now this is why I put what I did on the first screen. We need to take 3 to the x equals 7 and write it as log of whatever. So that's where knowing how to flip back and forth is going to be important. It will become log base what? 3. The base of your logarithm was the base of your exponent. Log base 3 of 7. Okay, now log base 3 of 7 is a number. And that is an ugly number that my calculator is now going to tell me. You have one of two options. Your calculator either has the option where you can just type that in, go do that, or if you have an older operating system, here is your quick reminder of how you do change of base, which is why we learned this yesterday. Change of base, I could do as log of 7 divided by log of 3. Now, this is 3 raised to something gives me 7. I know it's got to be a little less than 2. 1 point. I'm going to round it to the 10th today. 1.8. Any questions on that? Are we all figuring out how to do that on our calculators? We know where that log base option is on most of our calculators, or how to do our change of base. If you don't have that log base option, you have to know your change of base formula. Okay? All right, so this is variety 2. We have an exponent on one side. Let's see some other variations of that. Still an exponential equation, right? And e to the x is still an exponential equation. So e to the 2x plus 1 equals 8. Step number 1, get rid of all outside numbers. Do I have any vertical stretches or shrinks, any ROXs, any ups or downs? Nope. Okay, so we don't have any outside numbers, do we? That part's done. Step number 1 was done, which means now we flip to logarithmic. So this is going to become log base e, which is ln, natural log, of 8 equals the exponent. Guys, natural log of 8 is an ugly number that your calculator is now going to tell you. Somewhere around to the nearest 10th, 2.1. Okay, natural log is located on the left column of your calculator, like 3 buttons up, I think. Yeah? Okay, now ignore everything that we just had above this. That's just a simple equation that I need to solve. Subtract 1, divide by 2. This is a little bit different if you round or don't round in the problem. I think if you do round in the middle of the problem, it comes out to 0.6, and if you don't, it comes out to 0.5. I don't really care what you got there, but any questions? Okay, so I keep saying there's step number 1, that is get rid of all of those outside numbers, but we haven't seen that yet, so we do have one more of this type where we have some outside numbers. So let's look at one where we have some outside numbers. 8 e to the 2x plus 1 equals 21. Okay, so I need to solve this for my exponential term, which would just be the e to the 2x. What do I need to get rid of first? The 1. Remember how we solve an equation, right? How do I get rid of that 8? Divide. Oops. Okay, now we have done that first step. We got rid of all outside numbers. I subtracted 1, I divided by 8, I am down to my exponential, and once I get to that point, we flip to the other format. If I am currently an exponential, I will flip to logarithmic. Log base e, there it is, natural log, of 2.5 is going to be some ugly number, equals the exponent 2x. Natural log of 2.5 has got to be close to 1. 0.9 divided by 2. 0.5. Questions for me? Okay, so that's 2 out of our 3 formats. Now, I'm going to come back to this problem in just a little bit because it's going to look a lot like our next one. There's going to be a very, very key difference between them, okay? And that is this. We will have one specific type of exponential equation that looks like this. And the key is it has these 2 things. It has an e to the 2x, but it also has an e to the 1x. If it has both, okay, because our last problem had an e to the 2x, but it did not have an e to the 1x also. If it has both, then we will have to factor to solve our problem. Okay? So another way of looking at this problem, e to the 2x minus 2e to the x minus 3 would be if I were to look at it as a squared, that's your squared term, minus that's your plain a, minus 3. Can you factor that? Easily, right? So we factor it using the -3 and the -2 like normal. Factors of -3 that add up to -2 would be -3 and +1, right? The difference is the term at the beginning. When I multiply this number times this number, I get e to the 2x. And when I add those inside and outside, I get 2e to the x, which means that first term is just an e to the x. So, yes, I showed this one time. That's the last time you're going to see me do that because people then use a instead of e to the x. When I have an e to the 2x and an e to the 1x and I factor, the first thing in there will always be an e to the x and an e to the x. And then, guys, we're basically just down to 2 problems that we just had on the last page because at this point I would set everything equal to 0. Which means get rid of my outside numbers, so add 3. Flip to logarithmic, which would be a log base e, natural log, of 3 equals x. Natural log of 3 has got to be 1 point something. 1.1. Question so far? And then we go do the same thing on the other side. Subtract 1, flip to logarithmic, and my calculator tells me that is, why? Error. We just typed in to do the log of a negative number. Your calculator's not wrong. You can't do that. If I had seen this before, I could have stopped and already said, okay, now, the answer is not no solution. We have a solution, right? It just means that this is not adding anything else to our list of answers. We have 1.1, and that is it. Any questions on that? All right, then I'm going to let you try this one on your own once I get you started on the first step. Okay, so e to the 2x minus 2e to the x equals 8. What do I need to do first? Subtract 8, right? When we factor, it has to be equal to 0 before I start factoring. So go ahead and subtract 8, and you guys go from here. All right, so We know that that first term now, as we learned how to factor these, is going to be an e to the x and an e to the x. Factors of -8 that add up to -2 would be a -4 and a +2. Set each of those equal to 0 to solve. Once I get that e to the x by itself, I flip to logarithmic, so natural log of 4 equals x, and that's got to be 1 point something again, 1.4. And then you might see it happening already, and at any point that you see that this is not going to work out, you can stop, but I can go all the way to asking my calculator to do the natural log of -2, and it's going to tell me that I can't, and that reminds me that I don't get an answer when it is in negative. So we would throw that out and go back and say that my only answer is 1.4. Now, before I move on from this, just a quick question. Are we always just going to have one answer then of these type of problems? Yes, not always. When I factor, do they always have to be a positive and a negative? No, and that positive was making us have a no solution, and the negative was what was giving us a positive or a solution, right? So if these both ended up negative, wouldn't I get 2 answers? And if these both ended up positive, I would get no solution. So it is possible to have one answer, 2 answers, or no answers, right? Okay, so quick recap, because that's it. If you have this e to the 2x, e to the 1x, you're going to have to factor. You have to have both, because if we just have one of them, we get it by itself and flip to logarithmic, right? One exponential thing, get it by itself, flip to logarithmic. Exponents on both sides, get the same base. That's your 3 varieties. You just now have to identify which of those varieties it is and how I attack that problem. Your assignment, out of the book.